This is section 2.2, numbers 26 and 27, and I decided to do these in the same video because they're basically asking for the same thing. Just the wording is a little bit different, but the main thing to notice is like for both of them, it's saying for what values of x does your function f of x have a horizontal tangent line? So notice for both of them, they give us a function and they want to know where the function has a horizontal tangent. Also notice the interval that they give us for both of these. It's the same. It's basically saying they want us to look at the unit circle, the entire unit circle going around the circle one time from 0 to 2 pi. So I wanted to do these at the same time since they're basically asking for the same thing. For my number 27, I originally had a function that had cosine in it, but because my 26 had cosine in it, I asked for a different question and got one that has a sine in it. So for both of these, we're going to go through like two steps. So one thing is just to keep in mind that a horizontal line has a slope of 0, right? So because of that, we want our tangent line, like if we're saying that our tangent line is horizontal, we need for our tangent line's slope to be 0. Which means that for both of these problems, the first thing we need to do is find the slope of the tangent line. And remember, the slope of the tangent line is the derivative. So we're going to find f prime of x first. Once we have the derivative, we want to make sure that our tangent line is horizontal, which means its slope needs to be 0 because horizontal lines have a slope of 0. So we're going to take our derivative and set it equal to 0. And then we can solve that for x and we'll have our answers. So that's what we'll do for both of these. I wrote both of the problems down on my iPad. So I'm going to go ahead and switch over to my iPad. So for number 26, my function is 2 cosine of x plus x. Remember these two rules right here. One, that the derivative of cosine is negative sine. By the way, if your function has a sine in it, then you're going to use the other the other trig rule that we have, which is that the derivative of sine is cosine. So that's if you're that's if your curve if your function that you're given has a sine in it, then you'll be using that rule. One other rule that I will need for my problem, I'm not sure about yours, but just that if you have the derivative of a constant times x, you're just going to get the constant. So that said, if my function is 2 times cosine of x plus x, sorry, my function is 2 cosine of x plus x, so my derivative will be 2, so I'd bring the 2 down, and then I take the derivative of cosine, which is negative sine. And then for the derivative of x, keep in mind that what you see, keep in mind that the x is, it has a coefficient of 1. So it's like there's this invisible 1 there. And so since we have this constant times x, or 1 times x, the derivative will just be the constant, or it'll just be 1, that 1 there. Which I think I'll write in a stronger color so it's more visible. What color shall I use? I really liked that greenish color. but like it's not visible enough, I think. So I'll just use this kind of bluish color. This is blue. So +1 there. I think you can see that better. So my derivative ends up being -2 sine of x +1. So that's your first step. And then your second step is to set this equal to 0. So because I want the tangent line to be horizontal, which means the slope is 0. So my f prime of x is going to be 0. So I'll have -2 sine of x +1 equals 0. And notice I have a trig equation, which means I have to solve this the same way I solved trig equations before. So I'm going to get my sine of x isolated, which means getting rid of the 1. So I'll subtract 1 from both sides. So these cancel. And I end up with -2 sine of x equals -1. And then again, I'm trying to get sine of x isolated, so I'll divide both sides by -2. So these cancel, and I end up with sine of x equals +1/2. And then I'll go to my unit circle and see where it is that sine equals 1/2. And remember, on the unit circle, the sine values are the y values. So going over to my unit circle, I'm looking for where it is that my y values are 1/2. I know I'm going to be in the first and the second quadrant only because I'm looking for where sine is positive, or in other words, where the y values are positive. And that happens in the first quadrant and in the second quadrant. So I have 1/2 or y values of 1/2 at pi/6 and at 5 pi/6. So those are my answers, pi/6 and 5 pi/6. Let's see. I think all of these problems are set up so that the values that you get are actually on the unit circle. So I'm going to go ahead and enter these pi/6 and 5 pi/6. And there I go. So I'm going to do go through the same process for number 27. So once again, notice, did I not? I didn't write the function down. Like what? I can't do this without a function, can I? So let's see, my function, I noticed that it's x minus sine of x, which is why I said once again, because I saw that x right there. So it's like similar to the previous problem where there is an x there. So I'm going to use that same rule that the derivative of a constant times x is just x. So recognize that you have like a 1x here. And so when I find the derivative, I'll have f prime of x is equal to just 1, and then minus, and then the derivative of sine is cosine. So using this rule right here. So I have f prime of x is 1 minus cosine of x. And again, since I want a horizontal tangent line, I want my f prime of x to be equal to 0. So I want f prime of x to equal 0, which means I'll have 1 minus cosine of x equals 0. And then I want to get cosine of x by itself. So I think what I'll do is I'll move the cosine of x to the other side because it's negative on the left side. So I'm just going to move it to the right side. So it'll be positive. So I'll have a positive cosine of x. So I have cosine of x equals 1. And so now I'm going to see where it is on my unit circle that cosine is equal to 1. And now I'm looking for like the x values on the unit circle, or places on the unit circle where I have an x value of 1. That only happens one time if you just do if you go around the circle one time. You notice that the numbers on the axes don't really repeat themselves. Like you have +1 at 0 and then a -1 at pi, right? And then at pi/2 and 3 pi/2, the cosine values are just 0. So I only have this happening at 0. So this is like my answer. So just going back to my iPad, I can say that this happens when x is equal to 0. And I'm done. That's it. There's just one answer for this one. I hope that helps, and take care. Bye. You know what? There was something I was gonna say. I don't remember what though. What was I gonna say? I don't know. But I guess one thing I will see is to any of these problems that like were a struggle for you, just like repeat them over and over and over again. Like keep asking for a similar question. Do it again, do it again, do it again until it just feels just natural. Like that's how often you want to do it until it feels natural. Okay. Yeah, take care. Bye.